based on the equation E equal to minus Rydberg constant times z square divided by n square, certain conclusions are written. Which of them is not correct? In this equation, the Rydberg constant value is given in joules. This is the equation we use it for hydrogen-like atoms. This is from Bohr's theory. Equation can be used to calculate the change in energy when the electron changes orbit. Yes, this is correct. So, when an electron goes to the higher excited state, it comes back to the either to the lower excited state or to the ground state. That difference we can calculate using this equation. Here Z is the atomic number and N is the value of the stationary state. Option B states that for N equal to 1, the electron has a more negative energy than it does for N equal to 6, which means that the electron is more loosely bound in the smallest allowed orbit. This is not correct. Until this part, this is correct. So, when N equal to 1, because you have Rydberg constant, so let us just put it as Rydberg constant. Z value will be 1, 1 square is 1, N is also 1. So, this means that will be simply E equal to minus 2.178 times 10 to the power minus 18 joules. So, the difference is the value of N. So, this means that when N equal to 6, what will happen? You will be having a term 1 by 36 in that case. 1 by 36 times this value. So, that will be less negative compared to N equal to 1. So, until that part is correct. But will the electron be loosely bound in the smallest allowed orbit? No, it will be strongly bound. So, you have a nucleus here, you have an electron in the first orbit. So, this electron will be strongly bound rather than, let us say, the 2, 3, 4, 5, 6. So, rather than an electron that is in the N equal to 6 orbit. So, that statement is clearly incorrect. In option C, we have the negative sign in equation simply means that the energy of electron bound to the nucleus is lower than it would be if the electrons were at the infinite distance from the nucleus. This is correct, because when N goes to infinity, energy will be equal to 0. So, therefore, this statement is correct statement. In D, we have larger the value of N, the larger is the orbit radius. That is also correct. So, the incorrect statement here is option B. So, that is the correct answer.